This is a high school algebra lesson, Algebra 1 lesson on correlation, on making scatter plots and figuring out how to think about the data. Okay, so here we have a whole bunch of data. So this would have been something that we collected, like we were studying, dogs on the block. How many cats are on the block? How many dogs are on the block? We might have graphed it. Maybe there's some parakeets and fish and stuff in here. And as we look at our data, we put it on a graph to try to see if we can make sense of it. If there's some pattern or some way that we can understand a trend or what it might mean, or maybe that it won't mean anything. If there is a pattern or a trend, we call it a correlation. So let's look at one example and start with that, and then we'll talk about how we know how to deal with it. Okay, here we've got a graph. We've gotten a bunch of data. We've plotted it. Maybe this is the number of cats on the blocks and this is the dog on the blocks, or this is how much pizza you eat and how much you tip the driver, or does the pizza come on time and do you tip the driver? Is there a relationship between that and that? Okay, so we're looking at different things and we're trying to find a relationship. So what we'll do here is we'll say, well, here when the numbers are lower, like 1, 2, 3, 1, 2, 3, the graph where they graph is lower. So a lower one here corresponds to a lower one here. A higher number out here corresponds to a higher number out here, like that purple dot right there. Okay, that's kind of a relatively high X value, kind of a relatively high Y value, and this little green one right here, that's a pretty low X value, a pretty low Y value. Can I kind of make sense of that? Well, what I'm going to try to do, I'm going to look here and see, is there a place that I can draw that the line tends to be more above it or more below it? So I'll take this pencil. That'll work pretty good. So clearly, if I draw a line like that, half of it's above it and half of it is below it, but that doesn't show me that when the X value is getting bigger, the Y value is also getting bigger. So this really doesn't tell me very much. It's not untrue. It's not wrong. That is a line through the data, and about half's on the top and half's on the bottom, but it doesn't help me much. It doesn't show me a picture in my mind of how to predict what's happening. A line for this would more appropriately be drawn something maybe about like that. Generally, half above, half below. A few ones that are just weird, like these over here, don't hardly match up very good. We call those outliers. We'll talk more about that later. That they just, it just doesn't fit in the pattern. You can see a pattern, and the pattern is generally increasing. So we can draw a line then. Now this line is going to be subject to, a fair amount of your discretion. Like I think I'm going to put my line somewhere along in, here-ish, maybe to about here-ish, something like that. Okay, so I'm going to look at it, and I'm going to come up with what for me looks like a good line, and I'm going to go ahead and draw it nice and long so it'll cross the axes. Okay, that's a pretty good line. Some are further out, some are closer. That's kind of a good middle. Notice what I did not do. I did not pick two individual dots and draw a line on two individual dots. I'm looking at the dots as a whole group. And none of the dots have to actually be on the line. Looks like that one is pretty much on the line. That's about the only one. Some of them are close, some of them are far away. The point of the line is to be pretty much in the middle and to allow me to predict what's happening. Okay, so from this, I can predict that it's increasing. I can draw a line. There are times when I don't see a trend. I'm not going to always see a trend. This time I did. This time it appeared to be increasing. And once we do that, what are we going to do? Well, hey, this is algebra. We're going to write an equation. Okay, well, equations. That's going to involve, slope and point or intercept or something like that. So let's say that this point right here is 2. That's the y-intercept. And I find 2 places along the line that if I had a crosshair, that'd be where it is. So let's say I've got crosshair, I've got a graph line here that's at 4. And then I've got another graph line here that's at 8. And I look and see where that goes when it's on the y-axis to find out the point. And so let's say this is at 4 and this is at 6. Okay? How can I get the slope? Oh yeah, I remember rise over run. So let's use one of these nice handy little triangles here to help us with it. And so here we could, doesn't matter, you can do it on either side, the top of the line, the bottom of the line, doesn't matter. I'm just doing the top of the line because I am, no good reason. So there's rise, and there's run. The rise goes from 4 to 6, which is 2. The run goes from 4 to 8, which is 4. Okay, so the slope of this line is rise of 2 over run of 4 simplified to 1/2. Okay, what else do I need to write an equation? Well, what do I have? I have the y-intercept, and I have 2 specific points. I am blessed with lots and lots of data, and I get to pick. So since we know the slope, we know 3 points, one of which is the y-intercept you can choose. The most quickest way here would either be with point slope using any one of these 3, or with slope intercept using the intercept. I'm going to use the intercept. Okay. So remember, that's y equals mx plus b. And the slope is 1/2, and the intercept, the y-intercept b, is 2. So that's y equals 1/2 x plus 2. That is my trend line. That is my line of best fit. There's not always one, but there was one here, and that's it. Okay, let's look at what I just did and make note about it so that we're remembering. So here we have what we're going to do. To find, to make sense of the data. Again, we're trying to graph it and make sense of it so we can make predictions, so we can understand what's going on. We call the line that we drew a line of best fit. It fits the data the best we can, just kind of looking at it. Or a trend line, it shows us a trend. And one thing you could do about a trend with this, you could say, well, here's the equation, and it's going to keep on going. So what if I wanted to know what the value would be a long time away? So I wanted to know if this trend continues, what happens when it's been 20 units along. Here it's 4, here it's 8. What's it going to be when it's 20? Well, that would be at the point 20 for X, and we don't know Y, right? So I want to know 20 on the X-axis. So that is 20 and don't know the Y. So how would I find that out? Well, I could draw it longer, but I ran out of paper. Say, for example, if I just wanted to do 10, or what's the next one, 12, I could go here up to 12 and then go up to here, and it would be at 8. And so that I would predict after 12 units that the corresponding Y value would be 8. What if it's going to be 20? Well, I can put it in here. I can say Y equals 1/2 times 20 plus 2, or Y equals 10 plus 2, which is 12. Okay? So you could keep doing that. Any place that's on the line, you can just match up the Y and the X to see what it is, to predict what it would be at that particular value. So that is showing a trend. So how do we do it? We plot the data. This is all about data analysis to find the line of best fit, to be able to predict or show a trend. Plot all the data, the X's and the Y's, the dogs and the cats, the pizza and the tips, whatever you're doing. Plot it out. And then if you can draw a line of best fit, then draw it. You can't always draw one. We'll talk about that in a moment. Calculate the slope of the line. Rise over run. Remembering you are not using any particular points either to draw the line or to calculate the slope. The line is the one that you eyeball, the best you can tell how it fits, and then calculating the slope comes from the line that you drew, not from any of the particular points on the scatter plot. So here when I took this, there were points very close to it, up and down here and everything, but what I took was kind of the midland one to try to show the trend. So not the points, the line. So this is the procedure that you go through to do that. Then let's look at one that does not show a trend. Look at this. Okay, draw the line of best fit. Where's the line of best fit? Well, half above, half below, it's kind of all there. Maybe it's that. Okay, half to the left, half to the right. Pretty well distributed on both, about half each place, about here, about there. Okay, well, you could maybe draw one this way, maybe about like that, and make the argument that, well, it's a half, and it's kind of in the middle. Okay, all of those meet the criteria that it's about half, it's about in the middle. But you know what? One of them is not best. If there's not one of them that's best, then you don't do it. It's a line of best fit, or that shows a trend. This doesn't show a trend. It just says there's this stuff all over the place. I can't draw a line that's better than another line. That's the best line. I might draw one that's better, but not the best. I can have an argument that that's a good line. I have an argument that that's a good line. But I don't have a good argument that one is the best that I could draw. So there is no line of best fit. And we just say of this, there is no correlation. That the data does not show a pattern that we can calculate in something that's meaningful. Okay, how about this one? There's data here, there's data there. Where am I going to put my line of best fit? Let's see. Again, there's half on the left and half on the right. There's half on the top and half on the bottom. But that's the best. Somewhere along in there, it shows us that the data is generally going down. that it is correlated, there is a relationship, and it's generally going down, and I can draw me a line of best fit. This is subjective, and yet when y'all do this, y'all are all not going to be the same, okay? So, do your best. I would say, well, that's kind of sticking out there. These few outliers, I don't care about them. Okay. I would draw it kind of like this for my line of best fit. Okay? I think that would probably be a pretty close one. Let me do a little stronger here. Okay? Again, I'll do the same thing. I'll find my slope. I will find, and again, notice, did I get one? Oh, hey, I actually got a couple that are right on it. It is not important at all that the points be on the line. The line is simply to show the trend. And when I did it again, I might have drawn that a little bit lower. I think a little bit lower would have been fine, but I'll go with that. It's close. Yeah, I think I'd have put it about right there, a little bit lower. So what you'll do is you'll use your graph, and you'll find 2 x's, and you'll find 2 y's, and you'll calculate the slope again, same way as you did the last time. Now remember, whenever you do that rise over the run, you always have to do the reality check. If you come up with a positive number for this, it is wrong, because that's negative, because it goes downhill. So whenever you do a rise and a run calculation, always look back at the line that you're finding the slope of and do the reality check. I got that the slope of this was 1. You know what? It's not 1. It's -1 or something like that. So make sure that you've done that obvious thing. Once you've done that, you have 2 points that you could use in point slope. You also have the y-intercept. You do not have the y-intercept. You do have the x-intercept, since it's the 0 of it and there's a 0 in it. That would probably be an easy one to pick. But any 2 points on the line will give you the slope that you need, and then that is all that you need to do with regard to that. Then you'll write your equation like you just did. Okay, let's talk a minute about what these types of relationships mean. Okay. This, as I mentioned, is no correlation. We can't find a meaningful line that is better than the other line. And right now I'm looking for my one that I just drew. Here it is. Okay. We've said, so this is no correlation. Just like slope, we call this a positive slope. It is the line of trend of the trend line, the line of best fit has a positive slope. This is called a positive correlation. Okay? This is a negative slope, and it is a negative correlation. Okay, well, how do we do that? Well, let's see. Here, this one's negative. Notice that when the y gets larger, the x gets smaller. They do not go the same direction. The x gets larger, the y gets smaller. That is a negative. When one goes up, the other one goes down. One goes up, the other one goes down. As opposed to this one, as the x value increases, the y value also increases. This is a positive correlation. Both of them go up, or if you're going differently in time, both of them go down, depending upon how you're reading your graph. So if there is a correlation, it'll either be positive or negative. Either the two variables both go up or down, or they go different directions. Both go up or down is a positive correlation. Both go different directions, one up, one down, is a negative correlation. And if you can't find anything, there's just no correlation. Here's a little example listing that. You draw a scatter plot. You've had that in previous years. That's plotting all the data. If y tends to increase as x increases, both increase, then the data is called a positive correlation. If y tends to decrease as x increases, it's said to have a negative correlation. And if it doesn't make any sense to you, just say, well, relatively no correlation or no correlation. Okay? So let's look at a couple Let's look at a couple of problems here, and you think about them a minute and say, well, is there a correlation here? If there is it a positive or a negative? Well, you could argue some of these, and that's going to be the case as you do statistics. And when you start doing real fancy statistics in high school, we'll have a lot of things to say how close is good enough. Right now, we're just eyeballing it and getting an idea of the concepts, and then later we'll do more that's more specific with it. Okay, when I look at this one, I see a trend that basically goes like this. So I would call this a positive correlation. When I look at this one, I look at it and I say, well, that's pretty good. Well, that's pretty good. Well, that one's not bad. None of those are the best. None of those lines that I'm putting with my pencil are the best. So I'm going to say it's relatively no correlation. This one looks pretty tight. This is the clearest one here to me. I would call this a negative correlation, and I'd put the line down the middle like that. Okay. So a lot of this is your discretion. You're working with it, and you're trying to figure it out. Now this, give it some thought. Which of the lines shown is the better fit for the scatter plot? Think about your reasoning. Well, you're not going to get to talk back to me, but think about some of the reasons why you would choose the red line A or the blue line B, and why you think one would be better than the other. And here endeth the lesson.